Hello, everyone. We're starting up. Hello, welcome to the CQRS and Event Sourcing Architecture talk. This is going to be a very introductory style of talk to CQRS, but we are definitely going to go into some interesting practical scenarios. My name is Eugen. A little bit about me here. Don't try to pronounce my last name unless you're Romanian or Russian. I created my first event-sourced architecture early 2014. Really got excited about this stuff, about DDD, about CQRS. You can do quite a bit with it. Of course, not for every system, but there's really a lot to be done on top of the standard style of architecture. This is right now, it's my fourth CQRS implementation, so I've seen a few variations of this pattern. So if you have questions about the pattern at the end, definitely get back to me and we'll have a chat. So the goal of the presentation is to show you the way to architect a system with event sourcing. This is definitely a different style of building your architecture. And from my experience, the mental shift from going from a traditional CRUD style of architecture to an event sourcing architecture, that's really the main thing that holds people back, right? So you go to a talk, you see how it's done, but until something clicks, until you kind of see examples and like practical things that you can do with an event sourcing architecture that you simply cannot do with a standard architecture, you're not convinced. At least I wasn't convinced, and I've seen event sourcing architectures before, but yeah. It's going to be fun going through examples. So what's on the agenda? We're first going to talk about where CRUD still makes sense. Because CRUD definitely makes sense. Not everything needs to be CQRS, not everything needs to be event sourcing. However, if you have the kind of system that will benefit from event sourcing, it's a fantastic tool. We are then going to introduce event sourcing itself. We're going to talk about event-driven and especially why event sourcing is such a nice way to build an event-driven architecture. So event sourcing is relatively new, but event-driven has been here for a while. We are then going to talk about projections. And we're going to see, okay, the theory and how to do the event-driven style of architecture is well and good, but the problem is you still need to serve real customers, and you still need to basically be able to answer the standard questions that just a normal system is able to answer. So that's where projections come in. We're then going to touch on Spring. We're going to see where Spring makes sense, because there are various parts of this talk where Spring fits perfectly well into. So that's going to be like the practical aspect, right? So for example, Spring 4.2 came with the new event support. That's super cool. That's going to reduce a lot of boilerplate, a lot of extra code that you just don't need to write anymore. And you did need to write that before 4.2. We're also going to talk about the option to have polyglot persistence and what Spring Data brings to the table. Because Spring Data nowadays has support for most major persistence engines. So it's a fantastic way to write your projections. And at the end of the talk, we're gonna touch on microservices. Now, it's important to understand that while this is not specifically geared towards microservices, in the first implementation that we did with event sourcing and with CQRS, at the end of the implementation, when we managed to split our system and to basically put all of this stuff in practice, we did end up with a very solid implementation of microservices where most of the problems that you see in microservice architecture kind of go away because you go there naturally and you don't force microservices from the start. So we're gonna touch on that at the end. Now we're gonna look at an example. Imagine this is a CRM application. I chose CRM because most people know what a CRM is. It's just a kind of a customer management system. It has different definitions, but it's a relatively complex application. And you'll see why complexity and domain complexity is super important, because if you have a complex enough system, then CQRS, and then event sourcing makes sense. If you don't have a complex enough system, CRUD is fine. So for example, this application will have a few modules. It will have a lead management module where we're just storing leads, the leads that we have. They're not yet customers, they're just leads. We may have a lead scoring system. We may have a communication system where we're emailing people, we're SMSing people, we're phoning people. We may have a risk module, promotions, email automation, so a bunch of modules in this style of CRM application. And traditionally, this is the way you would build that, right? So you would have modularity. You would have these modules split and well-defined and with clear boundaries, but eventually most systems, not all systems, especially now with the microservice kind of push, but most systems are deployed in a single monolithical type of deployment unit. You have a WAR, and that's the way you deploy your system. Now, if you want to scale out that monolithical deployment, you're forced to pretty much deploy the same WAR, the same deployment unit on a separate box, right? So that's the typical scenario, which means that if one of those modules, let's say the communication module, simply needs a lot of I/O, right? Maybe it does a lot of networking, maybe it needs a lot of I/O. You don't have the option to separately deploy that on, for example, the right type of EC2, because we had the EC2 keynote. You don't have the option to deploy that on the right style of EC2 box, right? EC2 has a lot of boxes, a lot of types of boxes. They fit a certain purpose, but if you don't have your system split up, you don't have that option. And I've seen this in practice where going from a monolithical deployment to a clearly delimited and kind of modularized style of deployment with microservices had a huge impact on just budgets, like e-commerce stores going from 120 boxes in EC2 to 70, things like that. So significant impact. So this is basically where we want to end up, right? We want to end up with separate WARs. We want to end up with polyglot persistence. Each of these modules, each of these deployment units should choose its own persistence, right? Some of those may need standard SQL. Some of those may need, maybe they're doing a lot of, indexing and search style functionality. They might fit well with Elasticsearch, right? Some of them may need, NoSQL. Maybe they're doing a lot of math, like the risk module here. Maybe that does a lot of math, so you need a NoSQL type of store, maybe. So the point being that you have the option to deploy it like that. Now, I mentioned before, for simple models, for simple domains, CRUD is perfectly okay, and definitely event sourcing can be overkill. So it's important to understand your domain. It's important to know if you need CQRS or not, and if you need event sourcing or not. However, you'll find that the threshold of complexity for a domain is not as high as you might think. So a lot of systems that are moderately complex benefit quite a bit from event sourcing, quite a bit. Even simple system may benefit, but yeah, there is a threshold. Now, the introduction into event sourcing, the way I like to do the implementation part, because event sourcing is a big step. If you want to do event sourcing in your system, especially if you're not starting a greenfield development project, then event sourcing is a big step. There are ways, there are structures to introduce it gradually, but it's a big step. However, CQRS is a very small step. So you can implement CQRS in a system maybe in a few days. So in a few days, you can get a lot of benefit, even if you don't go all the way to event sourcing. So the CQRS in general, right? It stands for Command Query Responsibility Segregation. So what's the idea there? Well, the idea is to split up the reads from the writes. You have reads, you have writes. You want to split those up. You want to use different representations when you do reads and when you do writes. And just by doing that intentionally and across the board, because that naturally happens anyway, but intentionally means you do it from top to bottom for the whole system, you're going to get a lot of oomph, a lot of features that you could not have before. So, for example, and I think I have that somewhere around here. GitHub was attacked a few years ago. They were the subject of a denial of service type of attack. And what they did is they switched their entire system into read-only mode. So what they did is basically they had the option to say, OK, we're under attack. We're going to go down in a few minutes because our systems cannot handle that attack. Well, OK, we're going to switch in read-only mode. We're going to stop all writes across the board, but we're going to still be online. So that was a huge type of switch and architectural decision that they must have made at the beginning in order to be able to do that. And when I was kind of first seeing that type of response from GitHub, it occurred to me that my system being the system that I was currently working on, could simply not do that. Like there was no way that we could say, oh, we're going to switch up writes. No, there was no clear separation. There was no architectural decision that was able to enable us to do that. So basically, to kind of move past CQRS, this is one of the things that CQRS brings you. And the reason I mentioned that it's relatively easy to implement is that, of course, it doesn't require a huge like re-architecting of your system. It can be done relatively simply. We are in a Spring talk, so in a Spring ecosystem, you would probably have a lot of work in your controller layer, but not a lot more than that. So CQRS is definitely a good first step towards modularization and making this split intentional. So now we have these two concepts. As I said, we're going to make this split intentional. So this is, again, something that happens anyway in moderately complex systems and beyond, but we're going to make it intentional. We're going to put names on these concepts so that we can reason about our system much better. So writes become commands. It's a well-known pattern, and a quick example is create lead here. So create lead would be a command, right? So it's a command to the system. It is obviously a write because we are creating some data. We are changing the state of the system. And of course, we have the query for reads. So the whole point here is that you have this separation. And CQRS happens to be a good starting point for our event-driven architecture. It doesn't have to be. So I've seen CQRS. Well, CQRS without event sourcing is easy. But I've seen event sourcing. I've not implemented it, but I've seen systems that do event sourcing and that have no concept of CQRS. But these two things fit very well together, and CQRS just naturally leads into an event sourcing paradigm. So the reason commands naturally evolve into events, and we'll see immediately a quick example, is that you have the command represented by a present tense verb, right? So the present tense verb in this case is create lead. Now this naturally can be translated into a past tense verb, which is lead created. This is basically the event. This is the reason that commands very, very naturally evolve towards events. So what is an event? Let's first of all define our concepts. Events are something that happened in the past. That is what an event is. Because the event happened in the past, that has very interesting repercussions for our system. Because, okay, the event happened. That means a few things. That means that, for example, the event cannot be undone. Okay? It means that the event cannot be deleted. So it means, and we'll see in a second, it's going to have some immediate impact. So for example, this is a quick code example where we have a simple controller here, and this is of course a very basic example, but this is how we would process commands, and we would generate some event, right? So in a very simple scenario, you would have the create lead command, and that would simply generate, it would publish in the system a new lead created event, okay? So, how do we store events? Because that's the practical question is, of course, once you decide to do event sourcing, the first thing you need to do is decide how do you store these events. Well, we're going to store the events in an event store. There are many ways to do it. There's specific event stores implementations out there, libraries specific for that. But Postgres we found that was a perfect solution, and we're going to get to that in a second. Postgres was a very good solution because it has very nice JSON support, native JSON support, the new versions of Postgres at least. And so basically, we were able to use that and just store the events as raw JSON. And storing the events as raw JSON is super straightforward. It can be done quickly. It doesn't, it can scale, of course, up to a point. Postgres itself, has some limitations if you're dealing with like huge volumes of events. But for most scenarios, Postgres is more than fine. Events are stored in a sequence, of course, and there is a strict global ordering. What that means is that events have a timestamp, right? So events have a timestamp, which of course means that the event store is strictly ordered. Now that can be relaxed in some scenarios, but for the most part, a strict global ordering is a good thing, of course, and it enables you to do some interesting types of operations after that point. So systems that need to relax that constraint and don't need the strict global ordering, those are very rare and far between. Events are immutable once written to the store. So that basically comes back to what I was saying before, that an event is something that happened in the past. And if you consider the implications of what that means, it's a hugely powerful thing, because with event sourcing, it means that no data is ever lost. That's going to be the critical thing in understanding why you would need event sourcing. Why would you even go through the trouble of having an event sourcing system? Well, it's one of the only implementations that you don't lose data at all, which is, again, hugely powerful. And we'll go through scenarios of like what you can do with that. Like, why would it help not losing data? So because an event already happened, you cannot make it unhappen. That means deleting data is a new event. You cannot delete an event. Okay? Think about banking and transaction management. When you implement a banking system, of course, banking is naturally going to fall into this paradigm. This is the way the banking systems are implemented. You have your transaction log from the beginning of your account, and you can pretty much play that and stop at any point in time and know what your balance was 2 weeks ago, a month ago, a year ago. You can pretty much do that. And it's a purely additive model. You're never going to lose a transaction if they're doing their job right. So basically, that's the kind of the natural implementation. But we'll see why thinking in terms of events is fundamentally different than thinking in terms of just what is my current state. Like, what is my current state is what typical traditional systems do. Well, when you think in terms of events, that changes, that flips. Okay, before we get into more about that, this is a very quick, simple event implementation. So as I mentioned, Postgres is good for that. Postgres and raw JSON is perfect. Now, I've seen Elasticsearch implementations. I've seen a lot of other stores doing this, but yeah, Postgres is kind of my go-to whenever I implement a system. Okay, so now let's take a step back. So in the traditional architecture, you care about the current state. That's the only data you really have in the traditional architecture, unless, of course, you're building extra functionality to keep track of historical data. That's the only data you really have. Anything else, you need to pretty much custom build that. So anything else. Now, that's basically the only type of answer you can give. What is happening in the system? What is the current state of the system right this very moment? With an event source architecture, you know the state of your data at any point in time. So as I mentioned, we're going to store all events that ever happened. So event sourcing does do things differently. And because we're storing that journal of events, we can pretty much pinpoint to any point in time, and we can know exactly what the system looked like. So if you want to know, in our CRM application, okay, what were our leads 6 months ago? Well, if you don't have that data in your system, if you do a traditional simple type of architecture, you have no idea what your leads. You may have, maybe you have some timestamps when leads were created, but you don't really know what the state of your system was looking like 6 months ago. And now you can pretty much play the event stream up until 6 months ago, stop, start up your system and look at it. So you'll see all of the details that were representative of your state 6 months ago. So basically what event sourcing does here is it flips the traditional architecture on its head, and it basically makes current state a secondary citizen. It's still important. That's what I was saying, that we still need to answer those questions. We still need to say, okay, if I want to go and see my leads, I want to still be able to show my leads, right? I want to see what the list of customers or leads or whatever looks like right now. So that's still super important, but the point is, this is a secondary citizen. So in our CRM app, what would event sourcing be able to answer? What was the score of this lead last week? Okay, so when the score of the lead gets recalculated, you pretty much lose the last one. Unless, again, you're building something to keep track of everything, you're pretty much losing the last one. So you have no idea what the score of that particular lead was last week. So if you're, for example, debugging a production problem and you want to see, okay, why did we contact? Maybe we contacted that lead when the score of the lead gets over a certain threshold. Why did we contact him last week? Well, we have no idea because we don't know what his score was last week. Okay. So if that data isn't logged, then you're pretty much in trouble. What was the original author of this promotion campaign, right? You have a team, they're building a promotion, you want to see who started it, but if you're not keeping special track of that, you have no idea because maybe you overrode, you have overwritten the original author. Anyway, the point being that you have extra flexibility in your data, which for some systems may be, oh, okay, that's a cool type of thing, but maybe I don't need it. But for some systems, and we're gonna talk about a few examples, it's a fantastic thing, and it brings a lot of power behind your system. Okay. Now, as I mentioned, we still need to answer the questions about the current state, right? So the questions about the current state are still important. We still, of course, are building an application that, of course, the client has no idea that we're doing event sourcing or not, doesn't care. So we still need to do that. And the way we're going to do that, the way we're going to bridge that gap from the raw events that we're just storing as JSON, and we, of course, don't have very advanced querying capabilities over those raw events, we still need to basically be able to build a normal client, right? A normal application for the client to use. So in order to bridge that gap, we're going to start building a structure around the event stream, which is a projection. So this is basically a projection will react to some of the events that are flowing through the system, not to all of them, because the projection is very focused on a few questions or on a single question, the most extreme example, but generally it's able to answer a set of questions, and so it only cares about a very small subset of events. So a projection will answer that question. So basically what that means is that the projection will see all the events that are flowing through the system and will pretty much ignore most of them, and will only pick the data that it's interested in for the ones that are relevant for it. So why are we even using a projection? Well, a couple of things. First of all, it's able to answer those questions like about the current state of the system. It's also enabling us to do work in an asynchronous way. So basically, the user is not waiting for projections. Projection code runs asynchronously. The user is only going to wait for the event to get persisted in the event store, which coincidentally makes the system super fast. Now, another interesting thing that a projection enables us, because this is so focused on a single part of the system, it's not focused on the entire data set. It's not focused on the entire system. It's only focused on answering, for example, the lead management projection is only going to be focused on answering who are our leads, what are some of the details, like just raw data of those leads, who are our customers, for example. So just a simple type of persistence. Well, that means we don't need to normalize our data. We can work with highly denormalized data, which makes the data trivial to query. And that's also a huge benefit in terms of speed, because when you're querying that data, when your client and front end is sending queries, well, that's going to be, the data is going to be arranged in such a way that it's well adapted to answer those questions. So you're not typically going to have a lot of joins. You're typically not going to have a lot of, so basically you're going to arrange your data inside your projection so that it's super, super trivial to query, and it's going to enable you to query it quickly. So a very cool side effect from not having to normalize all of your data and having even the option to denormalize a lot of it. So let's look at an example. We went with a LeadCreated event because we can understand it very quickly. We're simply creating a lead. Now, what does this event actually mean for our projections? Well, for the lead management projection, it's going to simply mean I want to persist that, right? So I want to keep track of that lead data. For the lead scoring projection, the lead scoring projection doesn't necessarily care about the name of that user or whatever that lead data actually has. The lead scoring projection may only care about very few things, like, for example, where did that user, the lead, come from? Maybe it's a hot lead. Maybe they came through a promotion. Okay, well, in that case, it's going to get a high score, right? Maybe they came through cold traffic. Maybe they just landed on the site and, I don't know, signed up. So that means it's going to go to get a very low score. So the lead scoring promotion really ignores most of the data of the lead and just picks the parts that it really cares about. It does the computation asynchronously and ignores everything else. Well, the communication projection. So this probably cares about, because we're creating a lead in the system, maybe the system will email them and will say, welcome to the system or something, right? Or maybe we're gonna do a promotion. So the lead, the communication projection will not, again, care about most of those details. Will only care about, okay, what do we have to do to communicate with that lead? So you can see how different projections care about different things, pick different parts of the data, and just react and work on top of that data. They don't really care about the rest of it. All right. Now we're moving towards a real polyglot persistence type of architecture. So we can now see that each projection has its own persistence, okay, denormalized, well fitting the use case that it's trying to solve. So now we can see that not everything needs to go into SQL necessarily, although you can definitely have SQL projections. Some will fit more into the graph data, as I mentioned. Some will fit more into the indexed type of data, which is Solr or Elasticsearch or other index kind of search stores. So you'll basically use whatever fits best, which is something that you still have the option to do in a traditional system, but it's just much harder. This makes that very easy. And especially if you're working with large teams, having teams have the option to choose their own persistence when they're building a new projection is super powerful. All right, so projection data, I mentioned already, trivial to query. We're going to store it in such a way that it's going to be trivial to query. Now, what's interesting about the projection data, and this starts opening up use cases. This actually starts opening up, like, what can we do with this data? And what can we do with these projections? What's interesting about it is this is pretty much throwaway data. So you can throw away the projection data because that's not your primary data. The primary data is the event store. So if you want to throw away a projection, you can do that. Now, of course, in production, you need to have like a backup projection. You need to be able to switch between them if you want to throw it away. However, we've done that in production many times. For example, we had an in-memory projection running on a very large EC2 instance that had a lot of memory. And because this was in memory, it was blazing fast. However, we had the backup projection that was running separately, and that was persisting stuff to the database. And so usually we were going to the in-memory one, and the system was super fast, at least that part of the system. Well, now we always had the option to switch. And we did throw that in-memory projection away a couple of times, and we waited for it to rebuild. So you have that option to, okay, we have a projection, we throw it away, and we replay the entire event store from the beginning of time, and we rebuild that projection up. Now, that may not be practical, and we're gonna see how we can deal with that practicality, but that's definitely okay in most systems. Like if you're doing like an e-commerce store or a CRM, you're not dealing with like hundreds of millions or trillions of events that really are going to be problematic when you want to project them. No, you're dealing with let's say manageable number of events, and reprojecting all of the event stream is not really going to take that much time. However, we're gonna look at alternatives for that. So projection data can be recreated at any point. And not only can it be recreated, but we can stop, as I was saying earlier, we can stop with projecting the events 6 months ago, 3 months ago. We can look at the state of the system. We can understand what was going on. So that's why projection data is secondary data, and that's why it's super powerful that we can do this stuff with the system. Now, practically speaking, usually you'll have events that are kind of grouped into family of events. You'll find that as you're modeling your domain, you'll find that most events are kind of grouping and clustering together in some type of family of events. So practically speaking, you can, for example, in a Spring world, you can implement your events with a base class for the base like family of events type of class, and then just have children of that class representing your events. And that's why the new event support in Spring 4.2 is super handy in this case. And also on the Spring track, if you are implementing things like core Spring, the projection becomes a simple listener of those events. So you can basically hook into the core event support in Spring, which is pretty cool. Like you can, of course, roll your own event, event publishing mechanisms, or you can use things like Guava or other styles. You can, of course, go the message route as well. There are a lot of options to implement that, but generally speaking, if you're already doing Spring, this is pretty native and pretty idiomatic to Spring. So it's pretty interesting to see how Spring 4.2 helps there. So this is what things were looking in 4.1 and beyond 4.2 basically. So you had a lead projection listener. You had to implement the application listener here. So a lot of boilerplate. You had to do this, event is instance of event. Like basically you had to have your own code to drive this routing. So in order to route events to the right methods, you had to write your own boilerplate code, which was not fun. Now, obviously, this is not the end of the world. You can do that, and we did do that. But with 4.2, things become much nicer. So you now have no interface. You don't need to implement an interface. You just annotate this with add component, and you're done. It's a bin. You now have this event listener type of annotation, which means that you can have a very, very clean implementation where you just see on and the name of the event, and you have like a big, on lead created, on lead became customer, and so on. And that means there is pretty much no boilerplate. So, that was a nice addition to Spring. Now, when you do that, when you first start on your event sourcing implementation, some questions usually come up. For example, this is one that I get a lot, is a projection capable of undoing an event? Or is a projection a good place to put validation code? And the obvious question is, no, the obvious answer now that we understand what events are, is that no, it's no longer the point to put validation code. It's no longer able to do anything about that event. The event already happened. It's already persisted in the event store. So basically, the projection just reacts to the event. It cannot undo the event. So that's why it's important to understand that when you're reaching projection code, That's it. Basically, the event is in the system. So the time to validate stuff is in the beginning, in your event processing, in your command processing even. So that's why in the command example, we had like a little comment where I was saying extra validation, because that is the place to put extra validation if you want to validate something before the event happens. So the projection basically can project the event if it cares about it, or it can ignore it. Now, you may be thinking, okay, what if I'm using a system for a couple of years, right? Even if it's a standard normal system, you may still have multiple hundreds of thousands of events, if not millions. What do you do then? How can you actually replay all those events on top of a projection, on an empty projection? Well, you can. We've done that. We waited a couple of days. Of course, we had a backup. We had it was in production. Everything was fine, but we can do that. But of course, a better option here, and by the way, the reason we did that is because we were talking about that in-memory thing. And that's a little bit trickier to save. But the way to go here is save points. So save points means you have a projection, and each day or each hour, or depending on your system, maybe each week, you take a snapshot. You take a save point, and that means that you have a point to start from. So if you want to project the events, you don't have to do them all. You just have to project the last events. Like, for example, you have a save point from a couple of days ago. Okay, you're just going to project the events that happened from that point onwards. So that's much quicker. That can take a few seconds usually. So having those projections, of course, automatically backed up to S3 or some storage like that, where you have a clear process of restoring the projection and then replaying the events on top of that projection. Super useful and can definitely save your ass. All right, save points. The idea there is that so save points, great tool not to project events. I had a quick note here, just an interesting note from Greg Young, the guy that kind of pioneered most of this stuff. He said, for example, that he doesn't take snapshots until a projection reaches 1,000 events, which seems pretty low to me. But basically what he's saying is that if you really try to recreate a projection in this, on modern hardware, it's going to be fast. So you only need to have snapshots if you're dealing with a lot of data. Usually it's going to be even a couple of minutes, if you have a kind of a good backup, and of course you're not doing this in real time in production or anything like that. Restoring a projection is usually super fast. Now, we're going to go to some cool examples, because this is where things start becoming like, not just interesting, but really practical. Adding a new projection. Adding a new projection is something that in a traditional system, when you add some feature, and I'm gonna talk about an example in a second, you have to add it, and then you have to wait for new data to flow through the system, and basically you have to wait for stuff to happen when you add new functionality. Well, when you add a new projection in an event-sourced type of system, you can do something very cool. What you can do is you can add a new projection into your production system, and you can then replay all of the event stream through that new projection as well. So that means that it's going to have a lot of historical data that you don't have to wait for. Basically, all of the data, because you're not losing any data, all of your events, all of the changes in your systems are stored in the event store. You have that option. Now, let me kind of talk about a clear example of a company that did that. This was unfortunately not my own example. I would have liked to work on that, but it was an e-commerce company that had an event sourcing system that backed their e-commerce store. So they figured out that people were adding, which is pretty common knowledge, but they figured out that people were adding stuff to the cart and then removing stuff from the cart. So not the typical scenario where people are adding stuff to the cart but they don't buy it, which usually e-commerce companies are pretty smart to follow up with people and kind of maybe offer a promotion or remind them or something. No, these people were adding a product to the cart, and then removing that product. So what does that mean? Well, usually it means that they had some interest in that product, which the company was not capturing. So what they did is they added a projection which basically kept track of all of that. So they were now looking at, okay, who added a product, what product did they add, and they removed. So what happened there was they were able to promote that product to that person very specifically, and of course they had, I don't know exactly what the numbers were, but they had huge results with that, because it was a pretty, I think it was Macy's or an offshoot of Macy's. Anyway, it was a pretty big brand, and what they did is they had promotions going out to people for that specific product. So that was huge for them, because of course people were interested in that product, and that was a big thing. Now, in a normal system, you have that option, right? You implement that feature, you keep track of, okay, who added the product and who removed it, and you can do that. But the problem is they had historical, they had years of data in their system. They had years of event data that if you don't have an event source system, you're going to lose all of that data, and you have no idea who added something to the cart and removed it, right? Well, what they did is they replayed all of their event stream through this new projection, and they pretty much got years of historical data. And so they were able to market and have this kind of individual promotion for those people, and that's what the big kind of push was. And basically, again, I don't remember numbers, but they were pretty impressive to have that option and to promote to 1 million people at once, and actually have perfect targeting with that. So that was pretty cool, and that was definitely something that even if you implement in a normal system, you still have to wait for that data. So if you do that in a normal system, you'll have that going forward. You'll have that for new people that are adding new products to their carts and removing them, but you won't have that for historical stuff. And yeah, historical stuff was huge in that case. So that's just, that's kind of my go-to example, even though it's not my implementation, because yeah, it had a huge impact, a huge financial impact for the company, so that was pretty cool. Now, we have that whole data, right? We can build this new functionality as if it was there from the beginning. That's what I'm saying here, is that you can pretty much build it, but then the system is going to have all of that historical data, which again comes in handy with a lot of other things. Scoring, in our example, is one of them, of course. Now, we don't need to manually build a lot of stuff. Okay, if you do this right, you don't need to manually have code for audit, right? Audit logs, I'm guessing, most systems have an audit log. You don't have to manually build that, because that is what the event store actually is. It's a huge audit log, right? Versioning of objects, if you happen to be unfortunate enough to be working on a versioning implementation of your own, that's a big ball of mud, and that's tricky to get right. Well, versioning is, again, no longer a problem if you're keeping track of all of your changes, right? An undo action, pretty simple. Time series data, if you're doing any sort of time series, like reporting metrics, things like that. New reports, trivial to build on top of existing data. So the big takeaway here is that we have all of that data in the system, which in a traditional system, any deletes, any updates, right, that are overriding data are going to mean that you're missing data. You're already doing it. This is one of my kind of my favorite things, is that there are already a lot of things out there that are kind of doing this, even though they're not calling it necessarily event sourcing. Obviously, banking is a clear example where this happens, and this is the way they work. Search is usually a projection, because search in any system, you're going to save your data, and you're going to also index your data. So that's a sort of a projection. OLAP is a nice example of arranging data very specifically so that it can be queried, right? So that you can build nice reports on top of that. Audit logs, Git itself is kind of a clear example of that style of implementation. Now, moving past and kind of reaching the end of the presentation here, I wanted to go through a few more advanced scenarios, like, for example, visualize exactly how a bug occurred This is something that replaying the event stream gives you the option to do. Like you can pretty much, if you have a tricky bug, something that you pretty much have to go in depth and understand, okay, how did it happen? Like exactly what were the situations and what was the data before? Like how did we end up here? Well, you can pretty much play and filter everything out and just look at that particular user and very nicely just play event by event and kind of figure out exactly how you got there. So that's a super powerful thing that, of course, you have to build some extra logic in your system to do that, to replay like the events of a certain user. Well, but when you do that, it makes kind of evaluating and understanding complex scenarios very easily, because you can pretty much play and see exactly what's happening. So that was a kind of an advanced scenario that we did not have at the beginning, but and you don't use every day, right? Usually logs are enough, or maybe just if you're doing logging right, it should answer a lot of questions. But there are situations where you really need to understand how did you get to a certain state in your system. So no longer losing information. That's kind of an obvious takeaway at this point. We're no longer doing any deletes of data. Any delete is going to be a new event. So while the projection may be deleting some data, the event store never does. Updates, again, pretty simple example. Even if you're not doing deletes in your system, updates you definitely are. So you are going to lose some data when you update something and you override the old value. Update the projection and then replay the event stream. That's another advanced scenario that you can do. You can update the rules of the projection, not a new projection, an existing one. You can update the way that works. Like, for example, the risk management projection. Well, maybe you have a better approach to calculate the risk of a lead, right? Maybe you're doing financial work and you have to evaluate the risk of someone. Well, if you update the algorithm, you can play the whole system back. You can see what the new risk is, and you basically have that option from the very beginning, not just for new people. Trivially do migrations. Migrations are, sometimes another major problem. Well, when you're dealing with projections, migrations have nice built-in support, right? Projections are basically a perfect way to migrate, because you just start up a new projection separately, you play the whole event stream, and that's the migration. That's your new projection. Then you just make the switch. So migrations, no longer are that problematic. Caching an entire projection, I mentioned that in the beginning that we were doing that with a huge projection and with a pretty big, kind of an in-memory thing where we were pretty much caching the whole thing in memory just for speed, and we had this as a switch. Like we could always switch to the SQL-backed projection, and we did a couple of times, but most of the time the system was running off of that in-memory projection, which is a nice way to say caching, but it's also a nice way to kind of manage that, because we were using caching. Now, deploying projections. So projections naturally evolve into very independent, self-contained systems that can be deployed separately, right? So I had a big chunk of the presentation here, which I chose to kind of skip over, but if you're curious to see in a Spring system how to do that, grab a hold of me after this and we'll talk. Just very briefly, you don't have to get to the final step where you are deploying like a separate projection on a separate box in one go. You can start splitting up your Spring context. You can use child contexts there. You can start then splitting that up at the WAG level, but still, you can basically have a few steps up until fully separate deployments. But yeah, definitely get a hold of me after the talk. All right. So to wrap up, what are the major cons of event sourcing? Well, the first thing I would mention is the event sourcing architecture is definitely something you want to consider for each system. You want to basically be aware of your system, and you want to understand if it makes sense or not. The major con that I see, and that was the case for me as well, is the large mental shift. It is really a commitment. So if you know that your system is going to have a lot of upside, it's a worthwhile commitment, but it's a real thing. Like the mental shift of, okay, I'm watching a conference talk, but then actually doing it, that's a huge mental shift. It's important to pick the right events. Okay, when you're doing domain design and when you're kind of trying to figure out what events you want to use and the families of events, events are hard to change later on, okay, because you have the old ones, you still have to support the old ones, so it's a good thing to put a lot of thought into picking the right events. Now, sometimes that's obvious, sometimes it's not, but definitely important, because if you're not picking the right events, you can still do that. You can still change your events later on, but you'll have to support the old ones. So that means that on your projection, when you have those on LeadCreated, you can have on LeadCreated 1, which is the old one, and then the new one gets another number. So you can do that, but it's extra work. It's usually a good idea to put some thought into the domain in the beginning and into your family of events. The fact that the application now must handle eventual consistency is another con. Now, if you work with like the standard implementation of event sourcing, which has timestamps, that's a minor con, because your events are now, you can pretty much know when your system is consistent and when you have to wait by just looking at what is the last event that was projected. So basically, with timestamps, that's an easy thing to solve. And finally, microservices. We have not talked about microservices a lot, but of course, if you switch the word projection with the word microservice, and if you do this up until the very end, where you do have separate projections that are independently deployable, you basically have a microservice system. And so that's, one of the best ways to implement it is to naturally grow towards it. Not push it in the beginning, because there are many systems that do that, and kind of many horror stories in the industry. Well, having the projections drive that and kind of reach that state naturally is a good way to go. All right, and now a quick buzzword conclusion. So we started with CRUD. Okay, we kind of immediately went to CQRS, and we started looking at commands. Commands naturally evolved towards events and event-driven. We picked event sourcing, again, not the only way to do event-driven, but a very good way. We picked event sourcing. We saw that we needed to have something else beyond the event store. We needed projections. The event store is just not enough, okay? When you're dealing with a system like that needs to actually serve a front-end client, it's just not enough to have the event store, because there's nothing really queryable there. You cannot do a lot of advanced querying with raw JSON. And at the very end, we reached the microservices state, and we are done.
So, in a typical web application, let's say, who creates the event and where in the architecture the event is created?
So you're processing the command, right? When you're processing the command, let's take like the simplest possible example, as I was just showing there. You're processing the command, you have some validation, and then you're simply creating the event yourself off of that command. Now, sometimes it's not that simple. Sometimes the command goes to 2 events, 3 events. Like, it can do that. It can branch off, so it's not that simple. But generally speaking, the simplest thing is that you have the command, you verify that that command makes sense, and you want to create the event, because some validations may fail, and then you simply create the event and store it and return. So basically, the user doesn't wait for that. It just stores the event, immediately returns. The projections, of course, wakes up and starts processing that event, but that's asynchronous. So you're going to have the system that we were building was, weirdly fast. Like, it was unnaturally fast with that part. Of course, you do have to handle the eventual consistency, because you might, if you've worked with any scale, eventual consistency is a reality, right? So you have to handle that. Usually kind of the C in the CAP theorem, pretty easy to, let's say, handle from the front end, right? Like you have to know when you refresh your browser and you look at your application, you have to know that, oh, that's consistent. It's not like still catching up, right? But that's, again, that's easy to fix because you can pretty much wait for that timestamp to happen. It usually takes, I mean, in our system, it took like 40, 50 milliseconds, so very quick. So yeah, that's the way to create events. That's the way to create events simply. Again, it gets more complex if you're doing like multiple events off a single command, but that's the simplest way. Yeah.
Yeah. First me.
Hey.
So my question is, how do, if you have a distributed system, you may end up in a situation where you have you missed events, or you may get out of order events. I don't know.
So when you say you missed events, what do you mean?
You have the projection deployed on a different machine than your event source.
Right.
So
okay.
You have to pass the event off the network or something like that, so the projection may process it or not.
Yeah, so there are two things here. First of all, if you're processing events, if you're processing commands with multiple boxes, those, and if you want to keep the timestamps, of course, in sync, those do need to be aligned. So you need to be able to know that the timestamp on each box is the same. So that's number one. But then if you have projections that are separately deployed, then you need to use some sort of, for example, we're using Kafka for that. So we're using topics, and you do need to listen to those topics and have some sort of infrastructure to drive the wake up of the projections and the processing.
Okay.
So yeah, it's not, I mean, you can have this as a kind of simple implementation first, but eventually if your system grows enough, it's going to have to use Kafka, or it's going to have to use something.
Okay, my second question comes to this. What happens, so when you send an event to a projection, do you send all the event data with the event, or do you, just send the event and expect the projection to read the events from the...
So you send all the event data. The event data, then the projection picks the data that it cares about. Mm-hmm. There is an interesting advanced aspect here. Say that you're replaying the events in an e-commerce store, right? Well, those events may trigger, payments, for example, right? Someone buys something, you don't want to charge them again,
yeah,
right? Because obviously that's something that you need to be aware of. Well, you need to have a way to separate between I'm replaying events or these events are actually happening. It's a small flag, but you need to have that flag there. Because otherwise what happens is, in a simplistic scenario where you charge people when they purchase, if you replay that projection just for your development purposes or whatever that is, even in production, you may charge them again. So obviously you want to be aware that this time I don't want side effects. And so that's what that flag is called in our system. It's called side effects. And if that flag is turned off for the event, the projection knows to only store data but not trigger side effects.
Yeah. Thanks.
Yeah. So are you talking about the storing of events?
Not storing, processing from the listener perspective.
Right, so you're talking about either processing these events in a certain order. Well, it depends. So for example, the simplest implementation that we went into production with, yes, that was thread safe. So we built that in. We kind of... Is not. But what you can do is you can either build the thread safety mechanism yourself, or you can have the projection be smart enough to only process things in order of IDs. Because you do have IDs there, you have a normal, simple way to sequence stuff. So if you do have that, you can have the projection be smart enough to rearrange out-of-order events that if it gets out-of-order events. And there are other mechanisms as well. So yeah, Spring helps up until a point. Until like the single box type of implementation. Half of that, you need to build your own stuff. And by that, I mean, you need to leverage something like, Kafka was an example that I gave, but there are others. You need to leverage that. And Spring helps there as well. Like Spring Data, Kafka is a good implementation and a good client. there's like most Spring Data solutions work with like most persistent stores. So yeah, but you have to build your own.
For read code, do we use events?
No. So that was an abrupt answer. No, you don't. Basically, the event store is not really meant to be queried for any advanced functionality. The event store can be queried like from, give me all events between this date and this date, or give me an event by ID. And again, Postgres does have some nice support for JSON, but no. I mean, basically, any query goes straight to the projection. So that's why this is microservices basically, because you query the microservice. Okay, you're querying that, and that has the data nicely persisted, so that when you query it and when you have to wait for the answer, that goes right to the like denormalized way that it stores data, and that's super quick. You don't have to join a bunch of tables together. So you go straight to the projection.
One question.
Yeah.
I was wondering, in a typical system, for example, to avoid losing updates, you do something like that. You use versioning. So if I'm withdrawing $50 out of my $100 account, and then at the same time GitHub wants to withdraw another $50 because I have a paid account, they can use versions so they don't overlap. But in an even sourcing, if everybody creates an event, I want to withdraw 50 and I want to withdraw $70.
Yeah.
What patterns should I use to?
We're just getting to that now. That's a super interesting question, but keep in mind that we have three versions of the production system out before we needed to actually address that.
Okay.
But we're just getting to that now. We're going to use optimistic locking at the SQL level, so basically with those events. Now there is another interesting thing here, and this comes back to supporting events. If you change your mind, like you design an event family, and let's say you kind of learn something about your domain, and you say, oh, well, that maybe doesn't make perfect sense, right? Events itself can have versions. Like this can be the version 1 of the LeadCreated event, and again, you can increment that. So that is a bit unrelated to that, but to answer your questions exactly, we're using the database kind of support for that, because we don't want to build our own. We consider building our own and having some sort of locking mechanism and kind of signaling that. It depends. It depends in any system, of course, but my recommendation is to go with something that comes out of the box, because it's just going to be easier. Sometimes you may want to do that yourself, but I mean, we're not. Yeah?
I'm not entirely sure I understand why you need versioning if your event happens only after the action has happened. The action should not have happened if there was at any point in time any dispute between different. You should have.
So you're talking about the locking. You're not talking about the fact that I mentioned that I versioned my. Okay. So you still need some mechanism, right, where you're able to know when there's a conflict, right? Now you can, again, build that yourself, and that comes into that big validation block before the command gets processed and gets into the event. However, that's extra logic. So you might as well rely on the database because it already has those mechanisms. Now you can, of course, build your own. You can check the version, you can go back and see, is there any event that locks that particular resource, and then, kind of fail that command. So that's and that's what we try to do first. And it's doable, but it's just a lot of work. So, I mean, our solution was basically, rely on the built-in database mechanism for that. But I'd be super curious to see, and I think the event store library, there is an event store library that is built specifically for those types of scenarios. I think I've never used it, but I think it has support for that. I think it's called event store, but I might be wrong. But we'll put that in I'll put that in the final show notes.
Yeah, because you said the event gets emitted after the action.
It does. So logically, yes. Logically, you should do the processing in that validation, because logically it is validation. However, it's a lot of work, right? So you might as well kind of piggyback on the database for that. Okay, unless you want to build your own stuff and unless you want to do your own checks, which is fine, but we chose not to do that just because of the work. But yeah, logically, it makes perfect sense, right? Don't create the event if there's a conflict.
I had one question. If I need a projection twice, does it mean that it gets calculated twice?
No. And the reason for that is, so there are a couple of ways to do that. First of all, the mechanism of replaying the events should, just out of the get-go, should not allow you to, it's not even allowing you, should have no chance of replaying the same event through a projection, but you can basically keep track of the last ID that you processed and ignore everything below. So if the projection knows that the last ID that it processed has, its ID 1000, well, if it gets the event 500 again, for some weird reason, shouldn't, but if it gets that again, you can ignore it.
What happens if your projection relies on more than one? Sorry. What happens if your projection relies on more than one event? Let's say there are three
usually
events
does.
that are.
It usually does, yeah.
How can you correlate them? Should you emit a new event and you rely only on that one, or?
So a projection will usually project a few events, right? So for example, the lead management projection may project lead created, lead updated, lead deleted, lead disabled, whatever, right? Now these are independent events. So it projects them separately on their own implementation, like it has on lead updated, on. So with that point of view, that's simple enough. But if you're asking, like, what if a projection may need to generate another event, then that's also possible. But that does mean that you need to manually correlate them. What we did in our implementation, because we had discussions around, do we allow that? Do we allow a projection to trigger an event and basically start that process all over again? We didn't. And the reason we didn't is, and I've seen implementations that did, it's extra work, of course. We wanted to keep things simple. But the interesting fact was that our system is pretty complex.